You close your eyes and try to picture a color you've never seen before. Redder than red, greener than green, something completely alien, none of these appear. The screen behind your eyelids stays the same familiar palette. You can't do it. And it's not a failure of imagination, it's a blueprint limit written into the architecture of your brain. Your consciousness is color locked. And the reason why will change how you think about every thought you've ever had. Why can't your brain conjure a genuinely new color, one that exists outside the known spectrum? The answer forces us to confront a startling truth about the nature of imagination itself. Let's start with a philosopher. In 1690, John Locke, the British empiricist, raised what became known as the Molyneux problem. He asked whether a blind person who has learned to distinguish a cube from a sphere by touch could, upon gaining sight, tell them apart visually, and he answered no. But Locke went further. He proposed that a person who had only ever seen black and white could not imagine a color like red. Without the raw data, the brain has nothing to build with. This was not a scientific experiment, but a logical trap, and it set the stage for 300 years of research that keeps confirming the same point. Skip to 2015. Dr. Joel Pearson, a cognitive neuroscientist at the University of New South Wales, ran a series of experiments on mental imagery. He asked participants to visualize simple colored shapes, a red circle, a green triangle, and then measured the activity in their primary visual cortex. What he found was striking. The same neurons that fire when you actually see a red circle fire when you imagine one. Your brain does not distinguish between real input and internally generated simulation. That means your imagination is literally rerunning the hardware of perception. And perception only knows the colors your eyes can detect, a range limited by the 3 cone types in your retina. You have roughly 6 million cones in your fovea, each tuned to short, medium, or long wavelengths. That's the entire library of visual experience your mind has to work with. So where could a new color possibly come from? Now consider synesthesia. In 2003, Dr. V.S. Ramachandran at the University of California, San Diego, studied synesthetes, people who experience color when they hear sounds. One subject consistently saw a pure yellow when a piano played middle C. But here's the critical angle. When Ramachandran asked her to imagine a new sound-color pairing, she couldn't. Her extra connections were built into her brain's wiring. She could only ever see the colors her system allowed. The same is true for you. Your brain is a closed loop of sensory data. Every imagined color, every mental sunset, every hallucinated alien landscape is a remix of the approximately 1 million distinct shades your cones can theoretically distinguish. But that's it. The recipe book has a finite number of pages. Take it even further. In 2007, Dr. Bevel Conway at MIT mapped the neural representation of color in the human brain. He showed that the visual cortex organizes color into a kind of internal palette, a map where reds neighbor yellows and blues neighbor greens. This map is laid down by evolution over millions of years. It's not learned, it's wired. So when you try to imagine a color that is not on that map, like a reddish green or a blue shifted ultraviolet, your brain simply cannot find a place for it. It's like trying to type a letter on a keyboard that doesn't have that key. You can mash the ones you have, but you can't make a new one. Now, a skeptic might object, pointing to people who claim to see forbidden colors like bluish yellow. In controlled experiments, such as those by Dr. Hewitt Crane in 1983, subjects reported seeing impossible hues when their retinal images were stabilized. But those were perceptual illusions, not true novel colors. The brain was mixing existing signals, not creating a new one. And consider tetrachromats. Some women carry a 4th cone type, allowing them to see wavelengths most of us don't. A 2010 study by Dr. Gabriel Jordan at Newcastle University identified a tetrachromatic woman who could distinguish colors invisible to others. But here's the catch, even she cannot imagine a color outside her 4-cone range. She has a slightly larger palette, but still finite. Her imagination remains bounded by her biology. So the complication is real. We can expand the sensorium, but we cannot escape its architecture. What becomes clear is that philosophers and neuroscientists both land at the same frontier. We can name the theoretical possibility of a new color, call it grue or bleen if you like, but we cannot simulate the sensory experience of it. David Chalmers, in his 1996 book, The Conscious Mind, called this the hard problem, explaining why subjective experience feels the way it does. The impossibility of imagining a new color is a concrete example of that gap. We know the logic, we know the biology, but the actual quale, the first-person feel, escapes us. So what is known is that your imagination is biologically constrained. What isn't known is whether any intelligence, human or artificial, could ever break that constraint. Now open your eyes, you're back in the real world, surrounded by a full spectrum of colors you take for granted. But the next time you close them and try to picture something beyond that spectrum, listen to the silence of your brain's failure. That gap, that sliver where a new color should be, is not a flaw. It's a window into the limits of consciousness itself. You are not imagining a color that doesn't exist. You are feeling the shape of your own mind.